Hello and welcome to this video on how to run an item and scale reliability analysis for free in the Jamovi software. My name is Geiser, I'm an instructor with QuantFish. In this video I want to show you how you can run a free scale reliability analysis using Jamovi, which is a program that you can download for free from the internet. So let's get started. You can see I have Jamovi open here on my screen, and the first thing that I will do is open a data file. I can do that by clicking on the symbol here on the upper left hand side of the screen. And so I'm going to go to Open. Here you can see that Jamovi allows you to open data files in various formats, including simple text files, SPSS data files, or Excel files. Here I'm going to open an SPSS data file named math.sav. This data file contains a number of test score variables from various tests, including a math scale that we're going to analyze here. Now, where do we find reliability and item statistics in Jamovi? For that, we have to go to Factor. And then you can see the first analysis, or the first option here is scale analysis, reliability analysis. Below that you have options for principal component analysis, exploratory factor analysis, and confirmatory factor analysis. If you're interested in how exploratory and confirmatory factor analysis work in Jamovi, then I have separate videos here on this channel in which I walk you through these techniques, which of course are also relevant to item and scale analysis. In this case, we're assuming that we've already completed our factor analyses, that we already know the factor structure of our scale, and we're gonna go ahead and compute summary or composite reliability estimates. So let's go to reliability analysis. You can see that on the left-hand side you have your input screen that looks similar to what you would have in SPSS, where you have your variable list and you can select variables from that list. On the right-hand side you can see the output window where Jamovi has already prepared a table that will later contain the reliability statistics, and you can see Cronbach's alpha here is the default that is checked on the left hand side. So now Jamovi is waiting for us to select variables from our list. So I'm going to go ahead and I'm going to select 4 subscales from a math test. I'm going to click these over into the items field. On the right hand side you can now see that Cronbach's alpha was calculated to be 0.8. Now, of course, with Cronbach's alpha, we have to recognize, or we have to understand that there are certain assumptions that statistic is based on. Cronbach's alpha only makes sense to calculate when you have a unidimensional scale, meaning a scale that measures a single common factor. And not only that, but the single factor model also has to have equal unstandardized factor loadings. That's a model that is called a model of essential tau equivalence. And we're assuming that measurement error variables are uncorrelated. Under those circumstances, Cronbach's alpha then is a meaningful composite reliability statistic that gives you the reliability of the sum or mean of the items that comprise that scale. So in this case, if we were to form a sum score based on those 4 math subtests, then under the assumption of essential tau equivalence, the reliability would be estimated to be 0.8. Now, this means that 80% of the scale variance reflect true score variance, which is a pretty decent reliability estimate. So this means that only 20% of the sum score variance represents measurement error variance. Now, Cronbach's alpha doesn't always apply because not always do we have a single factor model with equal factor loadings. Sometimes the factor loadings are different between different scales, and then this is called a congeneric measurement model, where you have a single factor, but the factor loadings are allowed to differ between the subscales or the indicators of that factor. And so then, in that case, McDonald's omega is the better reliability statistic for congeneric measures. Cronbach's alpha for congeneric measures tends to be too small, so meaning it would underestimate the reliability. You can see here McDonald's omega is slightly larger than Cronbach's alpha, and that might have to do with the fact that the factor loadings here of these scales are not all exactly equal. So there's maybe a slight advantage here of using McDonald's omega, which would estimate the scale reliability to be about 0.82, meaning according to McDonald's omega, 82% of the variance in the scale are true score variance. Now, other things that you can display in the reliability table is the scale mean. So that would be the average number of points on that scale if we were to form a scale score. And then also the standard deviation can be displayed for the scale. Furthermore, we can also look at item statistics here on the right-hand side. We can look at Cronbach's alpha if an item is dropped. And so you can see for all 4 scales, if we drop one of those, then Cronbach's alpha would be lower. So this means we should probably not drop any of them. Also, McDonald's omega can be displayed if item dropped. And here we have the same result to where McDonald's omega would decline if we dropped one of the 4 scales, which means we should probably keep them. Also, you can display the item mean for each of the components of the score, as well as the standard deviation, and the item rest correlation. So this means how the item is correlated to the rest of the scale, which here you can see those are all decent correlations, meaning those items or those subtests are all important components for that test. It's really nice that you get these all in one table, and the table already comes in APA format, so you can directly export this table. When you right click on it, you can copy it or you can export it, and then you can add it to a Word document or a PowerPoint presentation. So that's really nice too. Furthermore, you can display a correlation heat map here, which means it's a graphical display of a correlation matrix. Here we see the Pearson correlations between the 4 subscales, and the stronger the correlation, the darker the green here. You can see that they're all similarly highly correlated, around 0.5 or higher, or some are a bit lower, but so roughly 0.5 on average. So that those are decent correlations for subtests that are supposed to measure a common factor. We can also address the issue of reverse scaling if we have items in a questionnaire, for example, where some are positively worded, some are negatively worded, and you want to recode the items, or you want to indicate which ones need to be recoded, then you can do that here. If you don't do that, you might end up with a negative Cronbach's alpha. And for example, and I have a separate video on that topic that you can check out on this channel as well. So this is very practical, that here Jamovi allows you to rescale the items appropriately. And in this case, it's not necessary. They're all positively correlated. But if you have some negatively correlated items that should be reverse scaled, then this is a useful option. Also, when you click on Save at the bottom, you can save the mean score of the scale and or the sum score of the scale to your data. It's also very practical. So you can, let's take a look at that. We can check these boxes, and then you don't see anything here because this is just for the statistical summary output. When you go to your data file and then to the very far right side of the data file, you can see a mean score has been added and a sum score has been added. So those are ways to summarize those 4 components of the scale into a sum score that then you already have in your data. So that's very useful. I hope you found this video useful to learn about item and scale reliability analysis in Jamovi. If you did, please subscribe to this channel. Also check out the description for additional resources, including workshops on factor analysis and psychometrics that I teach for QuantFish, and I'll see you next time.